Well, hey there, kiddos. Hope that you all have had a wonderful spring break and you're ready to get back to it. Before we start, make sure that you have grabbed that pink and white book that I gave you right before we went on spring break so that you can take your notes. And if you have lost that pretty pink and white book, you need to go to my website and print off another copy so that you have a place to take your notes. So we're going to start off today, we're going to start talking about quadratic functions. Everything we've done up till now has been a linear function and it's made a straight line. Now we're going to do quadratic functions which make curves. And the curves have a special name which we will talk about in a little bit, but we're going to start with the quadratic parent function. If you remember, the linear parent function is y equals x. Well, the quadratic parent function makes a curve instead of a straight line. And so the quadratic parent function, here's the definition. It's a parabola, which is the special name for the curve that a quadratic function makes. It has a vertex, which we'll talk about the definition of that in a little bit, at the origin, which is the point 0, 0, if you will remember. So it's got a vertex at the origin, which is 0, 0. And it has a line of symmetry at x equals 0. That's the line that's going to cut it in half. We'll talk about that. And one last little thing, it opens upwards. So when we look at it, it always opens up and does not open down. And we'll talk about all of those words here in just a minute. But that is the definition for the quadratic parent function. The equation for the quadratic parent function, linear was y equals x, quadratic is y equals x squared. Which is why we spent so much time talking about exponents and such prior to this, because they're going to come into play. They're going to come in handy. But y equals x squared is your linear, it's your quadratic parent function. When we graph it, it makes that definition that we talked about. So we're going to create a table based on this equation. The table's pretty easy. We know how to square numbers in our head. I'm going to start with 0. And if I plug 0 into this equation, I get 0 squared, which is just 0. If I plug in the 1, 1 squared is 1, 2 squared is 4, 3 squared is 9. Now we'll go backwards and do the negatives. When I do the negatives, I'm going to assume that I am plugging them in like this so that the negative is in parentheses because I want to square the negative. So negative 1 squared is 1, negative 2 squared is 4, and negative 3 squared is 9. So what you should see is your numbers repeat. So I go negative 9, 4, 1, 0, and then I go 1, 4, 9. That's what makes this symmetrical. It's going to have a line of symmetry. So we're going to plot these points over here so that we can graph them. So we start at negative 3 and 9. And then we go negative 2, 4, negative 1, 1, and then of course 0, 0. And then it goes back the other way. So I have 1, 1, 2, 4, and 3, 9. And so there is what our graph looks like. And when I connect the points with a smooth curve, we don't make a V, we make a smooth curve so it makes a U. This is what my linear parent function looks like. And so now I have a parabola, and this parabola has pieces which we will talk about in a minute, but I'll point out some of them to you. Your vertex here, which was in our definition, is at 0, 0. That is always going to be the point where your parabola changes direction. So it's where it goes from going down to going up or vice versa, but it's always the lowest point or the highest point of the graph. And then the line of symmetry, if you'll notice, the y-axis here, whose equation is x equals 0, cuts that in half. Everything to the left of the y-axis looks exactly like everything on the right of the y-axis. So let's talk about the domain and the range of this graph. So go back to things that we learned before. Domain, remember, is your x value, so it's everything from the left to the right, and this has arrows on the end, which means it goes to the left forever and to the right forever. So my domain is going to cover all real numbers, or it's going to go from negative infinity to positive infinity, which can also be written with the inequality format like this. Any of those is acceptable for the domain. Now the range, however, does not go for all real numbers, because it doesn't go down forever. It will go up forever, but it starts down here at 0. So it begins at 0 and it goes to positive infinity. And so I can't say all real numbers. Another way to say this is that I can say it's all numbers greater than or equal to 0 because it's everything from 0 and higher, or I can write it in bracket notation like this. Any of those is an acceptable way to write it. This one and this one is the way you'll see it more often than anything else, however. Now the vertex is the highest point or the lowest point, which we already discussed was down here at 0, 0. And my line of symmetry is the y-axis, and the equation for that is that x equals 0. We're going to talk about a connection between the vertex and the line of symmetry in a few minutes. And is it a minimum or a maximum? My vertex is what it's talking about. And so if you look at the picture, my vertex is the very lowest point on the graph, which makes it a minimum because it's the low point. And when it's talking about concavity, that last word that's on here, the concavity is talking about which direction does it open. This one opens up because my arrows are pointing in an upward direction. You could also have one that opens down, but in this one the concavity is up. And so we say this opens up. And so now let's label some pieces just so that we'll have them. We know this point down here is the vertex. It is also, in this case, going to be a minimum. It could also be a maximum. We'll talk about that later. We know that this line right here that cuts it in half is called the line, or sometimes it's also called the axis of symmetry, because it's the line that cuts it in half. And then these 2 points right here, there's one on the left and one on the right, they have the same names, and they have multiple names. This is called an x-intercept, because that's where it crosses the x-axis. Sometimes they are also called solutions, because the answers to any quadratic equation are going to be where it crosses the x-axis. Sometimes they're also called roots. And sometimes they're called zeros, because this is the point where y equals 0. And so all of these names can also go in this box because they have the same names because they're the same thing. Most quadratics have 2 of these. They'll have 2 solutions or 2 roots or 2 zeros or 2 x-intercepts. Sometimes they only have 1 and sometimes they don't have any, but we'll talk about that as we go through this. But all 4 of those names mean exactly the same thing. So let's turn to page 2, and we're going to talk about the line of symmetry and how to find the line of symmetry or the axis of symmetry for a problem. So standard form of a quadratic equation looks like this. It's y equals ax squared plus bx plus c. A, b, and c are constants, which just means they are going to be numbers that go in front of the x's or lack thereof. The x's, they're just your variables. It's just like y equals mx plus b. X just stayed x. So your x squared and your x will just stay x, but the a, b, and c are constants. And they're going to be important when we go to find our line of symmetry. This is set up to be an exploration for you to do a couple of things and walk through this. I'm going to give you the formula and we're going to use it. You can go walk through the table as we need to, but this first graph right here, the first thing it asks for is the vertex. Well, the vertex is up here at the top at -2, +2. That's its ordered pair. The line of symmetry is the line that cuts this in half. And so if you look right here, this line right here cuts that parabola in half. When I put a line right there, the left side now matches the right side, so that's like my mirror. So my line of symmetry is at x equals -2. If you will notice, the x value of my vertex and the line of symmetry are identical. That will always be the case. If you can find the vertex, you know your line of symmetry because it's the x value. However, you're not always given a pretty picture, so you can't just go grab the vertex and say, oh, well, that's going to be the x value. Sometimes you just have an equation, and so we have to use that equation to figure out the line of symmetry. Okay, so the function for this pretty picture right here is -2x squared minus 8x minus 6. A is the number in front of x squared, which is -2. B is the next number in front of x, which is -8. And if I want to find the line of symmetry, this is the formula. To find the line of symmetry, I use the formula, the opposite of b over 2a. And so I take my b value, which in this case is -8, and I change it, so I do the opposite of that, so b is 8. And then I do 2 times a, so I do 2 times -2. and then I work out that math. So I end up with 8 over 2 times negative 2 is negative 4. And when I do 8 divided by negative 4, I get negative 2. You see that this is the same number as what I had right here. So it depends on what you're given. If you're given a picture, go find the vertex, write down the x value. That's going to be your line of symmetry. If you don't have a picture, you only have an equation, you're going to use the formula. But for the next two, we're going to do we're going to do it both ways. So this picture right here, here's my vertex at 2, 4. So it's at 2, 4, which makes my line of symmetry is at x equals 2, so that they match. If we aren't for sure about that, then we come over here. A is going to be negative 1. B is going to be, positive 4. And so when I do the line of symmetry, I do the opposite of B, which is negative 4, over 2 times A. So I do 2 times negative 1. So I end up with negative 4 over negative 2. And when I do that division, I get 2. So they are the same thing. So I'm going to have you pause just a second. I want you to do this third one, find me the vertex, line of symmetry, and then do it algebraically, and then come back and check your answer. So I found my vertex. It's right here at 1, negative 4, which makes the line of symmetry at x equals 1, because they're the same thing. And then when I did it algebraically, I plugged in my opposite of b over 2a, and I got that x still equaled 1. So they're the same thing. So let's do a couple of more others. Line of symmetry is the vertical line. It has to be vertical, which is why the equation is always x equals but it's the vertical line that cuts the parabola in half so that the left side matches the right side. And so its equation will always be x equals. So for the next few, we're going to find the axis of symmetry for the parabolas. We don't have pictures this time. All we have are equations. So we're going to use these functions, and we're going to use this equation, x equals the opposite of b over 2a. And so for this problem right here, a is 2, b is 12. And so x equals the opposite of b, which is negative 12, over 2 times a, which is 2. So I end up with negative 12 over 4, and when I do negative 12 divided by 4, it's negative 3. So the axis of symmetry for this one is at x equals negative 3. Which also, by the way, gives me half of the vertex. I know that part of my vertex is going to be at negative 3 comma something, and so it gives me part of my vertex. Now number 2 here is a little different because I have an x squared, but I don't have an x, and so that's one of those, like when we factored these, because this isn't a difference of 2 squares, I would write it out. So I would have x squared plus 0x minus 7. It's going to come in handy when we do this. So a is 1 because there's an invisible 1 there, and b in this case is 0. So when I do my line of symmetry, I have x equals the opposite of b, which 0 has no opposite, it's just 0, over 2 times a, which is 1. So I end up with 0 over 2, and when I do 0 divided by 2, it's just 0. So my line of symmetry for this is at x equals 0, which means it's going to be the y-axis that cuts it in half. So pause again, see if you can do number 3, come up with the line of symmetry, and then come back and check. So I plugged in my numbers. A is 5, B is negative 20, so the opposite of B is positive 20 divided by 10, because 2 times 5 is 10, and that simplifies to be 2. So the axis of symmetry for this is 2. Now the last question on this page just wants us to put this in standard form, which if you'll remember was that equation way up at the top at the beginning that we did. The ax squared plus bx plus c, which means I've got to have an x squared, then an x, then a c, and I want them all in order, and I need it to say y equals. So basically we want this 3x squared and this negative 5x plus 4 to all be on the same side. There are a couple of ways to do this. It totally depends on how you want to look at it. I'm going to get this 3x squared and move it to the other side. That's what I want to do. And so in order to do that, I'm going to have to subtract 3x squared. And then I have to subtract it from over here. But see, there's nothing to subtract it from. So to make sure this is in standard form, it's going to start with a y equals. The x squared term comes first, so I have negative 3x squared. Then the x term minus 5x. And then the last term, which is plus 4. That is going to be in standard form. That's your equation in standard form. So you have your x squared, your x, and then your no x term. So it's now in standard form. So let's go to page 3. And we're only going to do half of page 3 today. We're going to do the top half and then we'll do the bottom half later. We'll come back to that tomorrow. But so we're going to now talk about the vertex. The vertex is, like we said, it's the highest point or the lowest point. And if you have a picture, it's really easy to find the vertex. If you don't have a picture, we have to work a little harder. And we will get to that in just a minute. But so we're going to start the first two that give us pictures. Tomorrow is when we'll practice finding line of symmetry, or sorry, the vertex without a picture. But for today, we're just going to find the vertex given the picture. So I have a picture. My function is x squared minus 4x plus 2, but they gave me the picture. My vertex is the lowest point right here, and that ordered pair is going to be at 2, negative 2. And then my line of symmetry, which since I have a picture is really easy, it's the x value of my vertex, so it's just going to be at x equals 2. And then is this a minimum or a maximum? Or it's the lowest point of my graph, so I get to say it's a minimum. And this, the arrows are pointing up, which makes it concave up. And then for my domain and range, well, my arrows point up. They also go to the left and right forever, so my domain is going to be all real numbers. With parabolas, it's really easy. As long as there are arrows on the endpoints, then it's all real numbers for the domain, period. Okay? If there are endpoints there, actual dots instead of arrows, then it changes. But if you've got arrows at the endpoints of parabola, domain is all real numbers. Now the range starts here and goes up. So there's two ways to write it. I can either say that it goes from negative 2 to infinity, or I can say that it is all numbers greater than or equal to negative 2. Either one of those answers is correct, and you will see either one show up as an answer. So you need to understand they mean the same thing. So the next one, I have this pretty picture. I've got my vertex. It's way up here. The ordered pair looks like it's at negative 2, 1, 2, 3, 4, 5, 6. With a comma there. My line of symmetry is the same as the x value, so it's at x equals negative 2. And in this case, it's a maximum because it is the highest point of my graph. And because this one has arrows that point down, my concavity is down. And my domain, arrows on the ends, all real numbers. My range, however, works different than this. Okay, because I have to remember when you do when you do range, you're going from the bottom of the graph to the top. Well, the bottom of the graph goes to negative infinity. That shouldn't be a comma. The bottom of the graph is at negative infinity, and then it goes up to positive 6 up here. So it goes from negative infinity to positive 6. And so I have to write this one in the opposite way that I wrote the other one. I can also say that it is all numbers less than or equal to 6 because it starts at 6 and then goes down. And so either one of those is an acceptable answer. And so there's the top half of page 3. If you got a picture, those questions are pretty easy to answer. So let's do the last one, page 4. Now we're going to graph some quadratic functions. We have a couple that we're going to graph. This is not what yours says, so I need to change it really quick. So now that should match. This should be what your paper says. It should say x squared minus 2x minus 6. If that's not what it says, I apologize. It means I did my math wrong, but I'm pretty sure that that's what it is. So now we're going to use this function and we're going to graph it. So the first thing that it says that we need to do is to find and sketch the axis of symmetry. So the first thing we have to do is find the axis of symmetry, which is at x equals the opposite of b over 2a, if you remember. So b here is negative 2, so the opposite of that is 2. A is going to be 1, so I have 2 times 1, and so it's at 2 over 2, which is at 1. And so they want us to sketch the axis of symmetry, which is at x equals 1. So it's a vertical line right here. I think I'm going to change colors. It makes it easier to see if I use the red pen. So my axis of symmetry is right here where x equals 1. I'm going to draw it as a dashed line so it doesn't interfere with my parabola. Now it asks us to find and plot the vertex. Well, I know that the x-coordinate of my vertex is going to be 1 because it matches the x value for my axis of symmetry. To figure out what the y-coordinate is, I got to plug this 1 into my equation. So I end up with 1 squared minus 2 times 1 minus 6. And I just find out what that equals. Well, 1 squared is 1. 2 times 1 is 2, and when I do 1 minus 2, I get negative 1. Negative 1 minus 6 makes negative 7. So my vertex is at 1 comma negative 7. And so it's here. So there's my vertex. Okay? So now it says to make a table of values using two values of x that are larger than the x value of the vertex. Well, my x value of my vertex is 1, so the two numbers bigger, which are 2 and 3. All right, you could pick two other numbers, but those are the easiest. And then I have to plug those into here to find out what the y value is. So I have to do 2 squared minus 2 times 2 minus 6. And at this point, I'm just going to grab my calculator and type that in. I'm going to have 2 squared minus 2 times 2 minus 6, and that gives me negative 6. And then when I plug in 3, I get 3 squared minus 2 times 3 minus 6. And again, I'm going to use my calculator. 3 squared minus 2 times 3 minus 6. And I type it all into one line. My calculator does order of operations, so there it is. So now I have these two ordered pairs. I have 2 negative 6, and then I have 3 negative 3. And so here are my points. And then, because this line, the dashed line I drew in, is the line of symmetry, I know that the left side has to match the right side. So these other 2 points that I drew, I just need to draw their mirror images. And so this dot is 1 space away from the line of symmetry. So to go the other way, I start at the line of symmetry and go over 1 space. And then this dot is 2 away from the line of symmetry. So when I go the other way, I'm going to back up 2 from the line of symmetry. So now I have my points. Connect them with a smooth curve, and there's your parabola. So now I want you to try it. Do this one right here. See if you can find the axis of symmetry, the vertex, plot your 2 points, use your symmetry, and make a graph, and then come back and check your answer. So there's my parabola. I got that my axis of symmetry was at -2, and my vertex was at -2, 3. And then I plugged in 2 values that were greater than the x value of my axis of symmetry, or the x value of my vertex. And I got these 2 points, 0, 1, and 2, -5. Here's the 0, 1, and here's the 2, -5. And then I used symmetry for my axis of symmetry to go and plot the points on the other side, and I connected with a smooth curve. Hopefully your curve looks a little better than mine, but that's what it should look like. So that's graphing a quadratic by hand. We won't do it a lot, but it is important to know how to do it. And so when you come to class tomorrow, this is what we will practice. I will see you then.